pleasant day to you, sir. I am Alice Rivera, a BS Ed Science student who will be presenting in behalf of my co-researchers, Miss Hazel Abu, Miss Elrime Pakit, and Miss Fuline Rodaza. By the way, today I will be presenting our research concept paper entitled Design, Construction, and Evaluation of an Improvised Linear Momentum Apparatus. Now, to fully understand a research concept paper, let us first discuss the topic in physics that is associated with our study. Linear momentum is the product of a system's mass and its velocity. In equation form, linear momentum P is equal to mv. You can see from the equation that momentum is directly proportional to the object's mass m and velocity v. The total linear momentum of the products must be equal to the total linear momentum of the reactants. Note that the linear moment, called simple momentum, is a vector quantity and is conserved at any direction. In the center of mass system, the total momentum is always zero, before and after interaction in any direction. This fact facilitates greatly the application of momentum conservation. Now, to fully understand the concept, we may apply experimentations to realize and visualize its applications. One example to that is the use of carts colliding each other, which is in collisions. Collisions are of two types. We have elastic and inelastic. And momentum remains constant in both type of collisions. Elastic collisions, the bodies collide and move away from each other, while inelastic collision, bodies move together after collision. And I'm pretty sure that we all have experienced that one during our laboratories experiment. We make use of the laboratory equipments that is available. However, we find some difficulties in getting desirable values or measurements. That is why our group have decided to come up with an idea to ease the manipulation and get the time efficiency. In this way, we collaborated to improvise the laboratory equipments. To start with, I will be discussing a brief overview of the problem. As future science educators, we focused on how we can impact science education in promoting better teaching learning as we recognize the vital roles of experiment. Aside from that, it boosts interest and motivations in their concepts thought. It also provides experiential learning, promoting knowledge construction and enhancement of science process skills. The subject physics involves the study of matter, motion, energy, and force, and it really requires practical work to allow students to better understand phenomena in the real world. So to do this, science tools like devices and apparatus are really necessary to visualize based on what is taught. Yet despite the importance of science laboratory tools in physics education, there is still an inadequate number of science tools and laboratories in the Philippines, both in public and private schools. And to add to that, teachers are not fully equipped in handling science tools. In many classrooms, software applications or physics simulations are widely used and promote excitement but pose learning disruptions and negative consequences. Even so, there are negative consequences that may cause disruption of learning, such as access to social media and other sites. Students may find it hard to connect to the internet, especially in remote areas. And with the advantages brought by software applications, we have found out that Other skills like measuring quantities, tests in physics are better learned through hands-on activities, but some apparatuses are considered to be outdated and obsolete, which means we badly need patience and it can be also frustrating to use as laboratory equipment made it longer. From this, so our study is focused on improvising an apparatus that will provide convenience in terms of ease of use to allocate more time. The researchers choose this topic, linear momentum, as we personally experience how it was done in the laboratory and difficulties we encounter. And with the aim of our improvised linear momentum apparatus that will provide ease of use, especially in measuring required quantities such as velocity and distance, to give more time to analyze the data. We believe that this could also serve as stepping stone or encouragement in the field of science education with the use of improvisation to address lack of science tools, especially in secondary schools, and enhance teaching learning concepts. So here are the research problem questions. So this study aims to answer the following. Number one, what is the mechanism of apparatus in reducing of non-conservative forces, measuring the speed of the object, determining the momentum of the object, and determining the change in momentum of the object. Number two, what are the user's perception on the use of innovative laboratory apparatus in terms of ease of use, portability, and reliability of a measurement? Okay, for the significance of the study, so for the students, they may find ease in manipulation and management, therefore more time to analyze experiment results. Exposure to a variety of physics apparatus can prepare them to complex topics. For the teachers, the apparatus may be used as one of the instructional material for physics teaching. For the university, the study can provide data about the perceptions of the users on improvised physics apparatus. Other educational institution, this will serve as stepping stone introducing the concept of adapting innovation and or improvisation of science tools for experiential learning. For the researchers, the study may serve as reference material for researchers in related fields. For the society, this can help students realize the use and application of science concepts in real life and therefore may contribute to the national development and economic growth. For the review of related literature, we've made a thorough research and we found out that there is really a lack of physics apparatus in Philippine secondary school as supported by Orleans 2007. That lack of apparatuses in secondary schools has been used to emphasize for the poor performance of students in science. Okay, for the importance of experiments in physics. So, according to U.S. Naval Academy's Department of Defense, experimentation is the practice of conducting experiments to test theories and provide the foundation for scientific understanding by demonstrating. An article in Science First stated that students' scientific thinking should be encouraged rather than forcing them to memorize facts. Okay. Measurements and measuring apparatus in physics. Measurements are based on units, and with this, scientists devised the international system of units to unify measurements. Yet there is still room for the uncertainty. Big idea physics. Many disciplines, especially in science, rely on measurements. That was according to Bulu 2018. So the importance of improvisation in physics. Okay, according to statement adopted by IUPAP 1999 physics, educators believe that science Equipment is an important means of demonstration, but lack of materials is highlighted as a problem in schools. And mastery of physics ideas cannot be fully acquired without the use of instructional resources. It was according to Oladeo et al. 2011. And many of the equipment used in teaching physics may be improvised. It was according to INAT 2012. We have also the effects of improvised apparatus to the motivation and interest of students in learning physics. The improvisation process of instructional materials exposes students to create, invent, imagine, get curious, want to try or test different possibilities. It was according to Adeniran 2006. Hands-on experiments and practical exercises can boost students' learning and build positive attitude towards science. It was according to Daniela Popesus and et al. 2015. Perception of teachers and students on the use of improvised apparatus. So using improvised instructional materials to run practical classes has polished and broadened instructors' skills to carry out physics experiments. It was according to Kira 2015. The results also demonstrated that students have highly good attitudes regarding using improvised materials in the classroom. That was according to Etokudo 2009. Teachers have a negative attitude about improvising materials. It was according to Juko 2000. Those who are aware of the use of loan one equipment and materials are hampered by a variety of circumstances. That was according to Jagedi and Adidayo 2013. Okay, for the research methodology, the study will adapt a descriptive quantitative research design whereby research experiment will be used, and the researchers aim to improvise a linear momentum apparatus in which it will be created out of materials that is locally available and can easily be replicated by some teachers to be used on their own experiment and demonstration of the concept. Before administering the improvised laboratory apparatus for experiment, it will undergo reliability test. The experiment will be conducted afterwards by the respondents. A survey questionnaire will be constructed to determine the respondents' perception towards the functionality of the improvised apparatus, especially in getting the variables indicated in the laboratory sheets provided to them. The research experiment will be conducted at one of the rooms at Building 41, Science Complex of the Physics Laboratory Department in the University of Science and Technology of Southern Philippines, USTP. So, the study will select the respondents to be subjected as the experimental group utilizing improvised laboratory apparatus in linear momentum. Okay, the participants of the study will be the 30 science teachers in the chosen 5 secondary public schools from Cagayan de Oro City. This means that there will be 6 science teachers from each school. Okay, for the research instrument, a modified laboratory manual about conservation of linear momentum will be utilized. A Likert scale survey questionnaire as an instrument with these categories: ease of use, portability, and reliability of measurement. Okay, for the data gathering procedures, so data will be analyzed using ANOVA, analysis of variance, mean and standard deviation to identify the descriptive statistics of the Likert responses. Okay, for the research milestones, okay, we have determined student learning outcomes and learning objectives of the linear momentum experiment, creation and consultation of the design of linear momentum apparatus, development of data collection form, construction of the improvised linear momentum apparatus, testing the validity and reliability of the improvised apparatus, implementation, We have the experimental stage and use of survey questionnaires. And lastly, data analysis. Okay, we were able to present our research concept paper on the webinar on leveraging research to impact education, an academic industry forum held on September 28, 2021. And we have joined also the Cash Awards, a student-initiated thesis category, with the help of our research advisors, Mr. Angelo Mark P. Walag and Mr. Lowell M. Gabunilas. So we were able to make it to the phase 3. From the consolidated advice of our physics instructor and from user, we had come up this design, but this is still tentative and we're still finalizing it. So we made some consultations also and discussed things including the design as well as the materials to be used. Now for the applications, okay, the tract consists of a variety of low friction carts and accessories to allow for the demonstration of many common motion concepts. The system is not as low friction as an air track but is much simpler to set up and use. Below are options that are available, but the system is not limited to this suggestion. A list of specific demonstrations that is used are listed below for reference. A fan cart to show the effects of an accelerating force. The fan can be angled to show vector components. There is a sail to show the effects of the impulse of the air on the sail. A mechanical driver and can set up oscillations of the carts with spring attached. Spring-loaded launcher to give consistent launching impulses. Bumpers for various types of collisions and Velcro to allow the carts to stick together. A friction pad to give the carts a consistent frictional force. There are several real-world applications of this phenomenon. One example is the use of airbags in automobiles. Airbags are used in automobiles because they are able to minimize the effect of the force on an object involved in a collision. Airbags accomplish this by extending the time required to stop the momentum of the driver and passenger. Fans of boxing frequently observe this same principle of minimizing the effect of a force by extending the time of collision. A boxer rides the punch in order to extend the time of impact to the glove with their head. Extending the time results in decreasing the force and thus minimizing the effect of the force in the collision. Merely increasing the collision time by a factor of 10 would result in a tenfold decrease in the force. Nylon ropes are used in the sport of rock climbing for the same reason. Rock climbers attach themselves to the steep cliffs by means of nylon ropes. If a rock climber should lose her grip on the rock, she will begin to fall. In such a situation, her momentum will ultimately be halted by means of the rope, thus preventing a disastrous fall to the ground below. Another common physics demonstration involves throwing an egg into a bed sheet. The bed sheet is typically held by 2 trustworthy students, and a volunteer is used to toss the egg at full speed in the bed sheet. The collision between the egg and the bed sheet lasts over an extended period of time since the bed sheet has some give in it. Okay, for the suggestions have been raised and we were able to use it and have take note of it. So that's the end of my presentation. Thank you and God bless us all.